Hey guys, it's Jamie here. So today we're going to be doing high-speed aerodynamics. We'll be covering 4 topics. Number 1 will be Mach numbers. Number 2, steady flow energy equations. Number 3, Mach waves. And number 4, normal shock waves. So let's begin. So number 1 is Mach numbers. We start with the general equation of a Mach number, where m is equal to c over a. C is the local gas velocity and a is the local sonic velocity. Sometimes a is referred to as the speed of sound, but this changes with temperature and substance, which varies with the value of gamma. Therefore, a is not a constant value. A is equal to the square root of gamma multiplied by r multiplied by T, where gamma is the specific heat ratio, r is the characteristic gas constant, and T is the local static temperature. We are interested in 3 main regions, where the Mach number is less than 1, where C is subsonic, where the Mach number is equal to 1, where C is sonic, and this results in C being equal to A. And finally we have the Mach number being greater than 1, where C is supersonic. For number 2, we have the corresponding steady flow energy equations, which describe the relationships between total and static properties. We are given these equations in the formula sheet, but it is good to be familiar with all of them. The temperature ratio is given as T subscript T over T, where T subscript T is the total temperature, where if the entire flow was brought to rest, the kinetic energy displayed is now displayed as heat energy rather than translational kinetic energy. And normal T is the actual temperature of the gas. Number 2 is the pressure ratio, which we can use because we are dealing with an isentropic process where the process is reversible and adiabatic. And finally, number 3 is the density ratio. We don't need to know these equations, but it is great to be familiar with them. So number 3, we have Mach waves. At GCSE, we did the Doppler effect, where the speed of the object is less than the speed of sound. If objects move at a speed greater than the speed of sound, then the pattern of the pressure waves changes. The wave fronts also produce a disturbance envelope bounded by the straight line, which we call the Mach wave. And finally, we have normal shock waves. Normal shock waves occur upstream of the blunt objects travelling at supersonic speeds. Everything in front of the shock wave is upstream and everything behind the shock wave is downstream. And we can see here that the properties are all different. Considering only mass, momentum and energy conservation for a wave with finite changes, we derive the normal shock wave relationships, where m1 is equal to the Mach number in front of the shock wave and m2 is the Mach number immediately behind the shock wave. We only need 3 properties to define moving gas conditions, and we only need 2 conditions or 2 properties if it is static. So that's all we have for you guys today. Don't forget to like and subscribe. If you have any questions or any comments to make, please leave a message in the description below. I'll see you guys next time. Bye!